of your bread and butter from Algebra 1, but a lot of you probably never got past graphing in slope-intercept form. So there's actually two other forms that your line might come in. And so as advanced mathematicians, I at least want to show you these two strategies if you've never seen them before. This point slope form is actually kind of the strategy we're going to use when we get to circles and ellipses. We're going to find coordinates out of the equation in this format. So you can always resort back to just slope-intercept form. So use the distributive property and just put it in slope-intercept form is fine. To make whatever decision you want on the quiz. I'm just showing you the strategies, and if you like them, you could use them. So slope-intercept form, I think we all know, right? So this is starting at -2, and the slope is just up 2/3. If you need a ruler, I can come give you a ruler. All right, so there's my line, right? Goes forever. All right, so that's slope-intercept form. So you can always put your function in slope-intercept form. So if slope-intercept gives you the slope and the intercept, what do you think point slope gives you? It gives you one point that lies somewhere on the line, and it gives you the slope. And I should have put in here kind of the formula y minus y1 equals mx minus x1 is the format of this equation, where x1 and y1 are a point that lies somewhere on your axis. And if you notice, but there's negative signs. So like y minus y1, this says y minus 3. So the 3 value of the coordinate is actually positive for y. And then see how this says x minus x1 in the formula? This x plus 1 is really x minus a minus 1. So the 1 in the coordinate is actually negative for the x. So the point, this is the hard part, I guess, if you've never done this before, the point is at -1, +3. So -1, +3 is a point that lies on my line. And we're going to do the same thing when we find the center of a circle or the center of an ellipse. We're going to read it out of this kind of x plus 1, meaning -1, and y minus 3, meaning +3. So -1, 3, you just kind of plot that point on your graph, and then you read the slope in front of that parenthesis with the x's. So the slope of this line is -1. When there's no number written, it's just, so this is -1/1, so down 1/1. So instead of starting at the y-intercept, you're just starting at that given point, and then you just do your slope the same way that you're used to. And I just want to prove to you, if I tried to convert this into just slope-intercept form, I get the same result. So slope-intercept form, if my original function was y minus 3 equals -1 x plus 1, this y minus 3 is not doing anything, so I just dropped the parentheses. You would distribute the -1 on the right. So y minus 3 equals -1x minus 1, and then you would just add 3 to the y-intercept. So -1x plus 2, and isn't that the line that we graphed, right? It had an intercept at 2 and a slope of down 1/1. So if you want to take the time to put it in slope-intercept form, be careful with your algebra. To me, it's easier to just graph it in the given form that it comes in. And then the other type is standard form. And you could convert this into slope-intercept form. I'll show it to you in a minute. But in standard form, what you do is you find the x and the y-intercept by plugging in 0. So if I plug in 0 for x, and I kind of cover up that 2x with my pen, what would y have to equal to make the equation true? 2, because 3 times 2 is 6. So when x is 0, y has to be 2. So 0, 2 is my y-intercept. Then I can cover up the other variable. If y is 0, what does x have to be? Because 2 times 3 is 6. So 3, 0 is my x-intercept, and you only need 2 points to graph a line. So you can just graph those 2 points, and there you've got your line. So standard form is another way that you can graph your line. And if I show you the kind of the proof that basically what you would do to put this into slope-intercept form, you would subtract 2x from both sides. So you would have 3y now equals negative 2x plus 6, and then you would divide everything through by 3. So y equals negative 2/3 x plus 2, and that's exactly what we graphed. Y-intercept was 2, and the slope was down 2 over 3. So you can also check your answers that way, but I want you to be really good at graphing lines because there's going to be a graph of a line on the SAT. They're going to ask you about the slope of it. Like they might give you this equation and say, oh, find the slope of this line. Or they might ask you, what line is parallel to this line? So you have to be able to find the slope to talk about parallel lines having the same slope. So it's good to be fluent with linear. So then down here, I've got a few more of those absolute value transformation practices that we can just do together. What are my two transformations on number 4? Just go up, down, left, right. Right 2, and then up 1. So this is moving me to the right, and this is moving me up. So right 2, up 1 is the vertex of my, it's a V-shaped absolute value graph. And they haven't flipped it and they haven't changed its steepness. So just up 1 over 1 from that vertex is your graph. And then number 5 hasn't moved up, down, or left or right. So my vertex is just going to sit at the origin still at 0, 0. But the slope is 1/2. So it's less steep. And I could just make it a slope of 1/2 and then negative 1/2 in the other direction. So it's a less steep V-shaped graph. So see if you can do number 6. There are 3 things that are happening to this parent function. So identify all 3 and then see if you can graph it on your own. And then we're going to do the piecewise function together at the bottom. It's flipped upside down with a steepness of 3, right? So 1, 2, down 3 over 1 would be your 2, 3, like that. Is that what we got? Okay. So being able to do an absolute value with a shift is definitely a must for tomorrow's quiz. All right, so piecewise functions, we're already on here, and then you kind of had questions from the homework about piecewise functions. So I'm not going to have you graph these on the quiz tomorrow, but they might show up on the test because it's talking about a linear function and it's talking about domain, both of which I want you comfortable with. I'm going to do some dots in pencil that you might not want to put on your graph in pen, but when I graph a piecewise function, I'm restricted by these domain values, and I just ignore them until after I've graphed my function. So my function is y equals, or f of x equals 2x when x is less than 0. I just ignore that for now, and I just graph y equals 2x. So that has an intercept at 0 and a slope of up 2 over 1. So I just like putting a few dots, and then I'll just figure out which dots I'm keeping and which dots I'm erasing before I connect them. So this says my x values must be less than 0. Here are all my x values that are less than 0. So I only want to keep these dots on the left side of that y-intercept. And actually, I need an open circle on 0, 0 because it says x is strictly less than 0. So an open dot means you almost get there, but then you actually don't get all the way to 0. So I'm going to erase those dots. To me, it's just easier to graph the line first and then get rid of what I don't need. So then the second line is the function y equals 1x plus 3. So that has a y-intercept at 3 and a slope of up 1 over 1. So I just graph that first. 1, 2, 3. And the slope is up 1 over 1. So that would have been my line. And it says x has to be greater than or equal to 0. So that would be all the points to the right side that I'm going to keep. I need a filled in circle on the y-intercept and going in that direction. So x values are positive to the right and x values are negative to the left. Does that kind of make sense? You probably haven't graphed many of those before, but I feel like, you know, as advanced mathematicians, you can graph a line and you can restrict the domain, then you can do piecewise functions. So it kind of fits in this kind of unit review of algebra. So let's do another one together and then you can try example 2 on your own. So I just look at that first function, y equals 2x minus 1. So my y-intercept is at -1 and my slope is up 2 over 1. So I'm just going to dot some points and it says my x values have to be less than or equal to -2. So I have to go all the way to -2 on the x-axis. So I'm going to keep this point that's down here at -2, -5, right? Because all my x values have to be less than that. And I'm going to get rid of all these other values. So I had to go all the way to -2, and then I got to keep all the points to the left of that. And this should be a solid filled in circle right there. And then what kind of a line is f of x equals 4 or y equals 4? It's what? It's constant. Yep. So what's the line going to look like? Horizontal line, right? So it's between -2 and +2 on the x-axis. So between -2 and +2, I just have this horizontal line at 4. And this should be an open circle. And then I have nothing over here. The graph just stops. So why don't you take a crack at example 2? We can put up 2 in a minute, but you can also move on and do example 3 and 4. In example 3, you're finding the intersection point. And in example 4, you're graphing an absolute value function. And then you're answering a couple questions about that. So try 2, 3, and 4 on your own. I'll put up the piecewise example in just a minute when you finish. So there's the answer to example 2. And then there are the answers to 3 and 4. And then you're doing the next page, the review sheet. And if you want to check your answers to the review sheet, I will put them at the end of this video. So pause it and try it first. I'm going to quickly skim through the answers to the review of 108. So you may need to pause the video, but I'll just quickly roll those graphs by so you can check your answers. That was the front page. And then here was the domain questions at the top. So pause the video. And then instantaneous rate of change is not on your quiz tomorrow, but here were the answers to that part.